Good morning to all. Today we are introducing engineering thermodynamics. What are the basic syllabus we can cover in our lecture series? I will explain. Before that, just briefly we will discuss about outcome-based litigation. Because at present everyone is telling outcome-based litigation. Who is giving that accreditation and BA committee? Tier 1 accreditation, Tier 2 accreditation like that. But earlier output based litigation. What is the difference that output and outcome? That's the main point, key point is there. Output based litigation means quantitative. My students got above 80 percentage. My all students got above 80 percentage. Very good is output. My institute having high qualified faculty. If they are giving knowledge to the student or not, that's a matter, not a matter. Having high qualified faculty, it's a quantitative method. But output based litigation, the quantity and quality both is required. Qualified faculty is required, but they are capable to inculcate some demonstration skills to the student. Then only that is called outcome based litigation. In outcome based litigation, my students got above 60% marks. No problem. There is no issue. But with that, some skills they have to demonstrate at the end of the course, the short term targets. Because students have attained within the 4 years of their degree, not 20 years, 30 years. Within 4 years, short term period, student has to attain that skills. That is important. That's called outcome based education. So, not attaining marks. Marks also required, quantity also required. With that, some skills are required. The skills are explained by the NBA committee. 12 skills they mentioned. We will discuss. So, in outcome-based education, a learner-centric education. What teacher teached is not important. What learner is learned. If institute having high qualified faculty, there is no issue. But that faculty is inculcating some demonstration skills to the student or not. That is assessed by the committee. What are that skills? So the main guide role of teacher is guide, mentor, and facilitator. That's all. So what are the skills expecting by the NBA committee? They given 12 skills. The first one, apply the knowledge up to 12th standard, whatever the science we studied, we are capable to apply that knowledge. Next, once you are capable to apply, the second outcome they are expecting, problem analysis. Because analyze the problem is important. Then once you, third program outcome, once you are capable to analyze, third one, design, develop solution. Fourth one, investigate, evaluation, analysis, synthesis is required. Once you design, you investigate your solution. A time consuming it reducing, cost is reducing. You want to analyze, investigate. The program outcome 5 is modern tool utilization. These 5 program outcomes are expecting based on our curriculum only by giving the syllabus and all. So these are the demonstration skills they are expecting with that marks. Only marks expecting, that is output based education. With the marks, some demonstration skill they are expecting. That's a skill. These are the 5 domain dependent skills. Domain independent skills is there by our teaching learning methodology. One is concerned about social, health, safety, culture, legal issues. That's PO6. PO7, environment and sustainability. Whatever the designings we are doing for our sustainable development without affecting the environment. That is the first point. How they are assessing based on the student projects. Next, PO8, commit to professional ethics. This is the first, the best quality we want to inculcate in the student community. Ethical practicing. Next, PO9, individual and teamwork. Because once we are moving to the industry, teamwork is very important. lead the team, leadership qualities, entrepreneurship opportunities. The students, the outgoing students, at least 1%, 2% students are moved to the deviating to entrepreneurship means yes, by our teaching learning methodology, we inculcated the teamwork and leadership qualities. Next, communication skills, graphical or oral communication, not speaking in language. Next, project management and finance. Whatever the projects we are executing, finance is important. Cost effectiveness that they are capable to demonstrate. In industry, that is very important. Next, lifelong learning. These 12 with that percentage, the student attains 60% or 50%. Above 50% also sufficient for me. But with that, these 12 skills they are capable to demonstrate. Sky is the limit for them, professional degrees especially. So, with the target, my engineering thermodynamics, I kept my objectives while teaching. Teacher have some objectives. What are the my objectives? Means I want to inculcate in the student community. First one, concepts of heat, work, energy conversion rules. One form to another. We all know the law of conservation of energy. So I am introducing concepts of heat and work, then conversion phenomena. Second objectives, application of first law and second law. That is my second objective. And third objective, to understand concept of entropy. Why? Because identifying the disorderness, feasibility of the thermodynamic process. Entropy means molecular disorderness. If you know the molecular disorderness, feasibility of the process also we can explain. Directional feasibility. Next, to familiarize steam properties to understand working of steam power plants. So I am introducing steam tables. Next, to familiarize psychometric properties to understand working of refrigeration and air conditioning. So in this unit, I am introducing two data books. One is psychometric chart, second one is steam tables. One is pure substance properties, one is psychometry, air properties. So this is my objective. Within 50 hours of tenure of my syllabus, in these 50 hours, I am capable to inculcate these are the concepts. By giving these concepts, I am expecting from the student. This is important. One is student will able to apply the energy balance compulsory for closed system, open system, whatever it will be. The student able to apply the evaluate and performance of the energy conversions by application of first law and second law. Next, third one, student will able to evaluate the available energy and entropy. Entropy concepts, what is availability? Once we know the molecular disorderness by the process is increasing, how much percentage increasing we know means unavailability we can calculate. Total minus unavailability will get the availability. Fourth one, the student can evaluate changes in thermodynamic properties and substance. These outcomes I am expecting from my course engineering thermodynamics. You see, I given mapping before starting the subject, the COs and POs. With these four COs, I can achieve three means strongly agreed means total I can achieve PO2. What is PO2? Analytical skills, problem analysis, designing the solution, and evaluation, apply the knowledge. So PO6, by my teaching learning methodology, the 6 to 12, I can achieve uh, 10, 11, 12. Okay, I can achieve lifelong learning. I am by my teaching learning methodology. This is my hope. So this is total before starting the subject I am giving. For this achievement, what are the syllabus? So I want to achieve these outcomes. How I can achieve? By framing of my syllabus. My syllabus contains 6 units. I will discuss the syllabus. So now move to the syllabus. In the first unit, we are discussing basic means we are introducing thermodynamics. It's like a thermodynamic vocabulary. One is classical thermodynamics, statistical thermodynamics, or microscopic microscopic approach, and thermodynamic terminology, system, property, state, path, process, equilibrium. Just we are introducing thermodynamics. Next, different process, quasi-static process, point function and path functions, and ideal gas, real gas, and Zeroth law of thermodynamics. So the unit 1 contains two parts. First part just introduction to the thermodynamic vocabulary, and second part work and heat transfer. We are determining the maximum work done of different process for non-flow and flow process. And what is the heat transfer? Just we are introducing the heat transfer, types of heat transfer in the first unit. The second unit, application of first law of thermodynamics. First law of thermodynamics we are applying for closed system, open system, cyclic process, and the evidence developed for first law of thermodynamics. Joules experiment we are discussing. Next, violation of first law of thermodynamics, perpetual motion mission of first kind, and first law applied for flow process, and correlations, the advantages and limitations of first law of thermodynamics, and some simple problems. Because once we solve the problem, then only we can enhance our analysis skills. Next, in unit 3, we are discussing second law of thermodynamics. There are two statements is there related to heat engine and the heat pump. Kelvin Planck statement and Clausius statement. Equality of the Kelvin Planck statement and Clausius statement means I am violating Kelvin Planck statement means it is also violation of Clausius statement. Next, heat engine, heat pump and refrigeration. Next, reversibility and irreversibility, and we are introducing one ideal cycle, that is a Carnot cycle. Remaining cycles all we are discussing in applied thermodynamics and Carnot theorem. Next, one more violated thermodynamic violated engine, that perpetual motion mission of second kind, violation of second law of thermodynamics. And here also we are solving some problems, evolution type problems. Practically the engine, proposed engine, practically feasible or not, like that. Next, unit 4 we are introducing entropy, the term, because the molecular disorderness is major driving force determination of the actual available energy. Energy means capacity to do work. Exergy, capability to do work. Now we require capability, not capacity. In each source of energy, you are capable to determine you are capable to determine the capability to do work. Exergy, the realistic designs are coming to the picture. Availability is there, capacity is there, but what is the capability? Based on the environmental condition, based on the process, the capability is changing. For that determination, the basic source, basic property we want to calculate, that is entropy, molecular disorderness. So Clausius theorem, definition of entropy, principles of entropy increase, and change in entropy in various reversible processes also we are deriving. Next, availability. Once entropy, you determine entropy into dead state temperature, you will get the irreversibility. Total energy minus irreversibility equal to, you will get the availability. So definition of exergy energy, expression for availability, irreversibility, availability, steady flow and non-steady flow process. So in this unit, thorough directional feasibility we are discussing in this unit. Next, unit 5, properties of steam, forms of steam from ice to superheated steam by visualizing different floods, temperature, volume, pressure, volume, temperature, entropy diagram. Because here only we are discussing about one pure substance, the pure substance universally available, pure, freely available pure substance is water, we all know. And quality of the steam, expression for change in internal energy, enthalpy, work, heat, entropy in various processes using steam tables and Mollier charts, using steam tables and Mollier. using steam tables and Mollier chart and simple problems on quality and dryness fraction. We are throttling operation. We are solving very good, interesting problems. So here we are introducing the pure substance. With these basics, in applied thermodynamics, we are designing the different types of the power plants and process. Next, unit 6 psychometry. Just here also some psychometry vocabulary we are introducing like dry bulb temperature, wet bulb temperature, specific humidity or humidity ratio, dew point temperature, degree of saturation, relative humidity. Next, the air conditioning methodologies, just sensible heating, sensible cooling, heating and humidification, heating and dehumidification, cooling and humidification, cooling and dehumidification. Six methods are there. We will discuss thoroughly that six methods. And measurement of psychometric properties using psychometric chart. So in this, I already mentioned, my objective introduction of utilization of the psychometric chart and steam tables. By using this one, we are designing the air conditioning system in applied thermodynamics. We are designing the power plant. We are evaluating the power plant performance by using the steam tables. So first basic engineering thermodynamics we are introducing. Later we are applying. So the major application of the engineering thermodynamics, the first one automobile industry, second one thermal power plants, third one HVAC, heating, ventilation and air conditioning. So once you are thorough with the basics of engineering thermodynamics, applied thermodynamics and heat transfer, plenty of opportunities are there. Industrial applicability, high level industrial applicability of basically these three areas. Power plants all are no more than 3 lakh megawatt thermal power plants are available. In India only, not worldwide. HVAC everywhere, commercial, industrial, household utilities. HVAC is a common word, and automobile also like that only. So plenty of opportunities are there. Just you are thorough with the three subjects. One is engineering thermodynamics, second one applied thermodynamics, third one is heat transfer. The basic subjects we are following. One is PK Naak, Engineering Thermodynamics, it's good textbook. Myself, I am following Singal and Bose, Thermodynamics and Engineering Approach. It's also very good textbook. Next one, Ramakrishna is our my Guruji. Fundamentals of Engineering Thermodynamics. It's also very good textbook. I think remaining Yadav, Mishra, some other reference books we are following. I think with this, I'm ending today's introduction. Tomorrow onwards, we'll start the individual topics of the engineering thermodynamics. Thank you. Thank you.